Hello students, today we are going to start another topic of chapter calorimetry. The objective of this chapter is to make you able to describe latent heat and specific latent heat. It is on page number 274 of your book. Let's see the topic we are going to discuss. We'll discuss about latent heat and specific latent heat of fusion, and we'll also study about the explanation of latent heat of melting on the basis of kinetic model. Let's see the first topic, that is latent heat and specific latent heat. Student, if you remember, you have done that when a certain amount of heat energy is given to a substance, it will undergo following changes. Number 1, temperature of the substance rises. Number 2, the substance may change its state from solid to liquid or from liquid to gas, which is called change of phase. But remember one thing, whenever there is change in the phase, there will be no change in the temperature, and when there is change in the temperature, there will be no change in the phase. It means that, for example, if this ice is changing into water, the thermometer will show temperature 0 degrees Celsius until the whole ice is converted into liquid. Now, when whole ice is converted into liquid, continuous supply of heat is there, but the thermometer is showing 0 degrees Celsius. Now the question arises, where the heat energy is going? Answer is, here the heat energy supplied to ice is utilized in changing its state from solid to liquid without showing any change in its temperature. It means that this heat energy is hidden. That's why this amount of heat energy is called latent heat, as the word means hidden. In the heating curve, you have studied that when heat is supplied to a solid, firstly its temperature increases, and after some time the temperature remains constant as solid turns into liquid. Again, there is change in the temperature of liquid, and again there will be a point where temperature remains constant as liquid turns into gas. Now, at this point, the amount of heat energy required to change the phase or to change the state of a substance without showing any change in temperature is called latent heat. This is the definition of latent heat. Now, when a solid changes into liquid, or you can say that temperature remains constant as solid turns into liquid, the amount of heat utilized by the substance at that point is called latent heat of fusion. On the other hand, when a liquid changes into gas, the amount of heat energy absorbed by that substance is called latent heat of vaporization. In both the cases, temperature will remain constant. Now let's see what is given in your book. 11.23 Latent heat and specific latent heat. We have read that during the change of phase of a substance which takes place at a constant temperature, a considerable amount of heat energy is absorbed or liberated, means absorbed or released. Heat energy is absorbed by solid during melting at this point, and an equal amount of heat energy is liberated by the liquid during freezing without showing any change in temperature. Similarly, heat energy is absorbed by liquid during vaporization at this point, and an equal amount of heat energy is liberated by the vapor during condensation without showing any change in temperature. Since the heat energy absorbed or liberated in change of phase is not externally manifested, means not externally shown by any rise or fall in temperature, it is called latent heat. Now next is specific latent heat. Students, specific latent heat of a phase is the quantity of heat energy absorbed or liberated by the unit mass of the substance for the change in its phase at a constant temperature. It is denoted by the symbol capital L. Its formula is L is equal to Q divided by M, where Q is the amount of heat energy and M is the mass of substance during change of phase. Now let's see what is the unit of specific latent heat. SI unit of specific latent heat is joule per kilogram, as SI unit of heat is joule and SI unit of mass is kilogram. So the unit or SI unit of specific latent heat is joule per kilogram. There are some other units like calorie per gram and kilocalorie per kilogram. Now let's read the book. Latent heat, when expressed for unit mass of substance, is called the specific latent heat. So underline this, unit mass of substance. Specific latent heat is denoted by the symbol capital L. The specific latent heat L is equal to heat absorbed or liberated for the change of phase divided by mass. If amount of heat energy Q is absorbed or liberated by the mass m of a substance during its change of phase at a constant temperature, then specific latent heat L is equal to Q divided by m. Thus, specific latent heat of a phase is the quantity of heat energy absorbed or liberated by the unit mass of the substance for the change in its phase at a constant temperature. The amount of heat energy absorbed or liberated by a given amount of substance for the change of phase for which specific latent heat is L is given as Q is equal to mass multiplied by specific latent heat L. Now let's see the unit of specific latent heat. The SI unit of specific latent heat is joule per kilogram. Other common units are calorie per gram and kilocalorie per kilogram. They are related as, now these are some of the relation between all these units and these are important. You must learn all these relations. Number 1, 1 kilocalorie per kilogram is equal to 1 calorie per gram. 1 calorie per gram is equal to 4.2 joule per gram. 1 calorie per gram is equal to 4.2 into 10 raised to the power 3 joule per kilogram. Now the next topic is specific latent heat of fusion of ice. Fusion means melting. Let's see. The specific latent heat of fusion of ice is the heat energy required to melt unit mass of ice at 0 degrees Celsius to water at 0 degrees Celsius without any change in temperature. So it is the amount of heat which is absorbed by the ice to become water at constant temperature, which is 0 degree Celsius. For ice, the specific latent heat of fusion is 3,36,000 joule per kilogram, or in calorie per gram, it is 80 calorie per gram. These are the constant value for specific latent heat of fusion of ice. You must learn this value. Now read the book 11.24, Specific Latent Heat of Fusion of Ice. The specific latent heat of fusion of ice is the heat energy required to melt unit mass of ice at 0 degrees Celsius to water at 0 degrees Celsius without any change in temperature. On the other hand, the specific latent heat of freezing of ice is the heat energy released when a unit mass of water at 0 degrees Celsius freezes to ice at 0 degrees Celsius without any change in temperature. Students, remember, for pure substance, specific latent heat of fusion is equal to specific latent heat of freezing. It means that the amount of heat energy required by a solid to convert into liquid is equal to the amount of heat energy released by the liquid to become solid. Therefore, specific latent heat of freezing of ice is also, yes, it is 3,36,000 joule per kilogram. Now, the question arises, What is the meaning of the statement that specific latent heat of fusion of ice is 3,36,000 joule per kilogram? The meaning of this statement is that 1 kilogram of ice, you can see from here, 1 kilogram of ice at 0 degrees Celsius absorbs 3,36,000 joule of heat energy to convert into water at 0 degree Celsius. In CGS, specific latent heat of fusion of ice is 336 joule per gram. Now read the book. Note number 1. For a pure substance, the specific latent heat of freezing is same as the specific latent heat of fusion. Number 2. For ice, the specific latent heat of fusion is 3,36,000 joule per kilogram, which is equivalent to 80 calorie per gram. It means that 1 kilogram of ice at 0 degrees Celsius absorbs 3,36,000 joule of heat energy to convert into water at 0 degrees Celsius. Or you can also say that 1 gram of ice at 0 degrees Celsius absorbs 80 calorie of heat energy to convert into water at 0 degrees Celsius. In other words, 1 kilogram of water at 0 degrees Celsius will liberate 3,36,000 joule of heat energy to convert into ice at 0 degrees Celsius, or 1 gram of water will liberate 80 calorie of heat energy to convert into ice at 0 degrees Celsius. Note number 3. 1 gram of water at 0 degrees Celsius has 336 joule or 80 calorie heat energy more than 1 gram of ice at 0 degrees Celsius, because 1 gram of ice required 336 joule of heat energy to convert into water at 0 degrees Celsius. Alright. Now, specific latent heat of fusion of some common substances. There are certain substances and their latent heat of fusion in calorie per gram and joule per kilogram. Number 1. Mercury. It is 3 calorie per gram or 12.5 into 10 raised to power 3 joule per kilogram. Sulfur. It is 9 calorie per gram and 37.7 into 10 raised to power 3 joule per kilogram. For silver, latent heat of fusion is 21 calorie per gram or 88.0 into 10 raised to power 3 joule per kilogram. Paraffin wax, it is 35 calorie per gram and 146 into 10 raised to power 3 joule per kilogram. For copper, its value is 43 calorie per gram and 180 into 10 raised to power 3 joule per kilogram. For ice, the value of latent heat of fusion is 80 calorie per gram or 336 into 10 raised to power 3 joule per kilogram. Now the next topic is explanation of latent heat of melting on the basis of kinetic model. Students, according to the kinetic model, solids are made up of atoms or molecules and there are intermolecular force of attraction between them. So the molecules in a solid vibrate about their mean position. All these molecules vibrate about their mean position continuously when we supply heat to that solid. The total energy of a molecule is equal to the sum of kinetic energy of this molecule due to its motion and its potential energy, which depends on the force of attraction between molecules and separation between them. Now, when a solid changes into liquid, there is no change in its average kinetic energy, but there is an increase in the separation between the molecules. Now let's see explanation of latent heat of melting on the basis of kinetic model. Article 11.25. According to the kinetic model, the molecules in a solid vibrate about their mean positions. The total energy of a molecule is the sum of its kinetic energy due to its motion, which depends on the temperature, and its potential energy, which depends on the force of attraction between the molecules and separation between them. When a solid changes into a liquid without any change in temperature, the average kinetic energy of the molecules does not change, but the separation between the molecules on an average increases. So, whenever a solid changes into liquid, there is no change in its kinetic energy, but there is change in the separation between the molecules, means their intermolecular space increases. As heat is supplied continuously to the solid, the heat energy is utilized in weakening the intermolecular force of attraction. Like this, all the bonds get weakened here. Now these particles are free to move and temperature does not rise. So ultimately what happened? The structure of the solid collapses. It changes its shape. The structure of solid collapses and cannot hold its shape. Ultimately what happened? Solid changes into liquid. Thus heat energy utilized during this change of phase is called latent heat of fusion or latent heat of melting. So during all this process, all the heat which is utilized by this solid is called latent heat of melting, which only changes the phase of the solid. Now let's read the book. Now some energy is required for increasing the separation against the attractive forces between the molecules, that is, for the increase in the potential energy of molecules. Since the increase in volume is negligible, so no heat is used in volume expansion. Thus, the heat energy supplied during melting is utilized only in increasing the potential energy of the molecules and is called the latent heat of melting or latent heat of fusion. Note: when 1 gram of ice at 0 degrees Celsius changes to water at 0 degrees Celsius, nearly 336 joule energy is used in increasing the potential energy due to increase in intermolecular separation. So, latent heat of ice is 336 joule per gram. That is the reason there is no rise in temperature, because all the heat energy is utilized to increase the intermolecular separation and there is no increase in the temperature. Now you are able to answer all these questions. Question number 1. What do you understand by the term latent heat? Question number 2. Describe the term specific latent heat of fusion of ice. State its SI unit. Write the approximate value of specific latent heat of ice. Question number 4. The specific latent heat of fusion of ice is 336 joule per gram. Explain the meaning of this statement. And fifth question is, which has more heat? 1 gram of ice at 0 degrees Celsius or 1 gram of water at 0 degrees Celsius? Also give reason. That's the end of the topic. Thank you.